In this video, let us start making our character controller. The way this is going to work is we will make a very simple character controller script all in one script. And then later on, let's break it out, use that state pattern, and let's, refactor our character to work using the state pattern instead of just being all in one script. But I think this makes sense to, do all the basic code in one script and then learn about the pattern and refactor the code rather than doing them both at the same time, which could become a little more confusing. So to start, one of the basic parts that we are going to use that Unity gives us is something known as the character controller. So to my player object here, to my player game object, I'm going to add component, and I'm going to search for character controller. And the character controller comes with a bunch of stuff, one of those things being its own colliders. So in my capsule that I had added last time, I'm just going to remove the collider component and use the character controllers component because that comes with the component. And all I'm really going to do here is just adjust the radius and the height so it more matches the player size that I have. So what does the character controller really do for us? It provides us with some basic functionality. The character controller has a move function that we're going to make use of, which takes like, a movement, and it's going to move the character in that movement. And this does a couple things that it handles for us. It's going to handle the collisions. So if we move into walls, it's not going to let us move past them. If there's a slope, for example, you can see there's a variable here called slope limit. Well, it's going to let us move up and down slopes. If we increase the slope limit, it's going to let us move up and down bigger slopes. And it provides us a very basic set of features for any kind of character that we want to move around. If you have used Unreal, Unreal also has a character component. We can make a blueprint of type character. This is similar, but just in the vein of again, how Unreal and Unity is. The Unreal character component is much more fleshed out. There are just so many things built into it. Unity is a little more bare bones, and it gives us the basic functionality of our character component. Some of that being this collider, again, the moving on slopes, not running into walls, etc. One of the things that it doesn't give us that Unreal does is gravity, so we're going to have to add our own gravity into this. You can see that if I just move this character up here, there's no code attached, but I have the character controller. And I hit play, they're not falling down. So gravity just isn't something that's a part of the Unity character controller, something that we're just going to have to add. With that being said, let us make a simple script first. So I have made this character movement script. This is going to be our controller. I didn't want to name it character controller just because this component's already named that. So instead of confusing our verbiage, I'm just going to call my script character movement. The first thing we're going to need in the script is access to the components inside our player, right? We have two components here. We have the input manager that's going to help us get the inputs, and we have a character controller component. So let's first get access to those. So I'm going to make a variable of type input manager, and I'm just going to call it input manager with the lowercase I, and we need a character controller. I could also call this character controller with a lowercase I. One of the things you might see if you watch Unity tutorials is some people tend to just call the Unity-based components by just naming them with the letters that they start with. So character controller would be CC, for example. If we so we could just name it that, and I'm going to name it CC. And so in our start function, let us get access to these. So our input manager is going to be equal to get component. Oops. Get component input manager. And our character controller is going to be the same thing, get component character controller. Next, let's just set up some variables that we're going to need, that we can use to customize our character, So I will give these some headers to make them nice and organized. We'll call this first section movement. and it's going to have an option for our move speed, which is going to be a explode, and we'll just give it some default value. So I'm just giving it 4 by default. You can do whatever you want. And serialized field. Let's add another float, and this is going to be our sprint multiplier. So when we hold the shift key, we're gonna like multiply our speed by the sprint multiplier. Let's have some options for our jump values. Oops. Let's add jump height. So how high we want our player to jump. Again, I'll just give it some random value like 2. Let us add a float for our gravity. And we'll just give it like the real world kind of value of gravity, which is minus 9.81 meters per second. We'll talk about this later, but we are going to add a float, and I'm going to call it ground stick. And we'll just give it a negative value. Basically, when we're on the ground, we're just going to kind of be pushing ourselves on the ground with this ground stick value. I'll just talk about why when we get to it. And finally, the only thing that we need under a references category, because we are getting these 2 references up here through code, is a reference to our camera. Okay, that just sets up some of the variables we need. If we need more, we can add them in as we go along, but these are going to be the basic stuff that we need. So let's talk about what we want to do every single frame in our update, right? What we need to do to get our character working every single frame. Well, step 1 is we are going to read the inputs. Fairly straightforward. We're going to use the input manager class and read the inputs. Step 2 is we are going to get our relative facing direction. So we are going to see what direction is forward for us and what direction is right for us. Because when we move forward, we need to move relatively forward, right? We're moving forward in the direction we're looking. When we move right, it's also relative. It's based on that direction we're looking. So first we need to construct those. We need to figure out what is our forward, what is our right, and it's going to be based on our camera, because our camera and our facing direction are going to be the same. After that, we are going to deal with jumping. And gravity. And finally 4, let us construct our movement vectors and move. So we'll actually let our characters, or we'll get our character to move. So let's start with the first bit. Let's read the inputs. Actually, to start, I need to make some inputs here. So what I'm going to do, just for organizing it, oopsie. I'm going to move these down here. Delete them from here. And I'm going to add some private variables for my input. So we need a private vector 2. That's going to be our move input. We need a bool that's going to be our jump input. And we're going to need another bool that's going to be our sprint input. So we have a reference to our input manager class. So every frame, let's just read all our inputs. So our move input is going to be equal to our input manager dot move input, whatever that is. Our jump input is going to be the same. And same for the sprint input. Next, we need to get our camera's relative direction. So we'll first update our transform, our camera transform, with camera. Again, this is a capital C camera. This is a global class that we all have access to that holds a reference to all the cameras, specifically a camera called main. This is the main camera in the scene. We only have one camera in our level, and that this camera.main refers to that camera. And so we can get its transform. Next, we need to get, like I said, that relative direction, right? What is forward, what is right? And to do that, we can make a new vector, vector 3. I'm going to call this forward. And what it's going to be equal to is vector3.project on plane. We're using a special function here called project on plane, which is going to take the cameras forward as the base vector. And it asks us the second parameter, if we can read right here, says plane normal. I want it to be on the ground, like flat on the ground. What is the normal of the ground? It's pointing straight up. So we will use the world up, which is vector3.up. And this, all this is going to do is it's going to create a forward direction. It's going to, if our camera is like tilted up or down, it's just going to flatten that against the ground and make a nice flat vector. It's basically removing that up and down component by taking whatever our forward vector is and projecting it onto the ground, making it flat. We do the exact same thing for the right vector. So we'll do cam.right. And same thing, I want to project it onto the ground. So vector3.up. Next, we got to deal with, or actually, even before we deal with jumping and gravity, let us just construct a small, like a movement vector using this forward and right vector. And all we're going to do is we're going to make a new vector 3. I'm just going to call it move. And that is going to be equal to our forward multiplied by our move input dot y. So y, the y input here is W and S, right? That's the forward axis. So we're just multiplying it. So if we're not pressing anything, the move input will be 0. Whatever our forward vector is multiplied by 0 is 0. So it's like kind of turned off. If I press W, the move input dot y will be 1. Whatever forward times 1 is going to be forward. And if our move input is S, it's going to be -1, right? So whatever forward times -1 is that opposite direction. We do the same thing with our y. Let's just add it to it. So right multiplied by move input dot x. So exact same concept. If we don't have an x move input, which is A or D, right will be zeroed out. If it's positive, right will be what it is. If it's negative, right will be flipped to left. And then let's deal with gravity. So the main thing I need to do is on every frame, we need to add some gravity pushing us downwards. And I'm just going to make a variable to kind of hold just the gravity part. So I'm going to make it a vector 3 just so we can like remember that gravity is y. And we will call it gravity velocity. So on every frame, gravity velocity, we're just going to keep adding our gravity to it. So on every frame, gravity velocity plus equals to our gravity value. And because we're like, setting it something based on movement, let's just multiply it by delta time so it gets scaled. I don't want to set the whole of gravity velocity. I just want to set the y value. So every frame, we're just going to keep adding to this gravity velocity, and it's going to be the thing that pushes our character downwards. And we'll get back to the actual bit of jumping after this. Let's just construct our movement and get our character moving. So our movement consists of two kind of different motions. We have a horizontal motion and a vertical motion. The vertical motion is up and down. That's kind of what our gravity is doing. And the horizontal movement is what we move on the Z and X plane. It's our movement on the ground. So let's make two variables for that. We'll have one vector 3 for our vertical movement and one vector 3 for our horizontal movement. The vertical movement's fairly simple. All it is it's going to be a vector 3 where we don't have any horizontal components. So x is 0 and z is 0. But the y component is going to be our gravity velocity. Oops. Gravity velocity dot y. And again, because this is a movement-based thing, let's just scale it with time dot delta time. Same thing for horizontal, except our horizontal here is going to be whatever our movement vector is that we've constructed as our relative movement vector. So it's going to be that multiplied by our move speed and multiplied by, again, time dot delta time, so we're scaling it correctly. And finally, on our character controller, we can call the move function with horizontal and vertical. I'm sorry, not comma. It's going to be horizontal plus vertical. So we're just adding our two movement components, and that's going to be our final movement. So let's save this and test it out. First thing to do is add the character movement into the player as a component. We're going to add it. And I realized I made this cam a serialized field, but we don't actually need it as one, so I'm just going to remove that part of it. In fact, we don't really need this references header. And we don't need cam to be a serialized field. Why? Because in update, we're just setting it to this camera.main.transform. So really, it can just stay a private variable. And so now, when I hit play, I can move around with WSAD. And again, if I'm holding W and I'm looking around, you can see we're moving to that relative forward. You know, whatever direction we're looking, we're moving relative to that. Same with the right. So that's done correctly. If I walk off this edge, my character falls. I think an easier way to see that is to just move our character up here. And you know, they're going to fall. So we have gravity working as well, which is great. Okay, so the next thing we're going to deal with is jumping. So when should we jump? If, and I'm not thinking about a double jump or anything, that's going to be its own kind of logic. But for regular jumping, if my character is on the ground, then if my character is on the ground and the jump button has been pressed, my character should jump, right? Hopefully that's fairly straightforward, and we can construct that. So one of the functions, or one of the variables that the character controller gives us is something called is grounded. So if we're touching the ground, if there's any ground below us, this is going to be set to true. Otherwise, this is going to be set to false. So one of the things is if our character controller is grounded and if the jump input's true, so if jump input, then in here we want to jump. The parameter that we are using for jump is jump height, right? So it's not jump speed, so I can't really just directly set the speed. I wanted to achieve this jump height. And there's a small formula for that. Really, what we are going to do is take this gravity velocity dot y, and we're going to set it to the square, so math.sqrt, I'm sorry, the square root, so math.sqrt of 2 multiplied by the opposite of gravity. Our gravity is negative, so we're doing the positive, multiplied by the jump height. So this formula is just going to make it so we can reach our jump height. And this shouldn't be math, it should be math F. And so again, let's see if this works. So I'm going to hit play. While I'm falling down, I'm going to be spamming spacebar just to show you we cannot jump when we're not grounded. We couldn't jump there. We hit the ground. I hit spacebar. We can jump. Again, if I spam jump, we can't jump in the air. And one nice thing about this one is if I hold jump, well, it's going to keep jumping. If you wanted to change that, you got to add additional logic to make sure it's only on the first time that we press it, not afterwards. But that's simple jumping. We have jumping working. So one of the issues and the reason that I added this ground stick variable here is Unity's is grounded. The character controllers is grounded. It can be a little iffy, especially if you're walking on like bumpy kind of terrain or something. If we leave the ground even for a frame or so, that is grounded is going to be set to false. And so it's not going to feel very consistent for our player when they are playing the game. The jumping isn't going to feel very consistent. And so what we can do to deal with that is if we are on the ground, let's just keep adding a very small downwards force that kind of sticks them to the ground. You know, we're pushing them against the ground just by a little bit. These two units, we're just going to push them by that into the ground just for that little bit of consistency. This is kind of like a common, again, pattern you see in Unity games specifically. So if we are grounded, and our gravity velocity dot y is less than 0, let us just set our gravity velocity dot y equal to our ground stick. So if our character is grounded and they're not moving upwards, there's no upward velocity to their gravity velocity, so basically if we're not jumping, let's just stick them to the ground. And this, again, we won't see much of a difference in this flat plane that I have, but this is just good for keeping our jumps consistent across kind of other things, other types of terrain specifically. Next, let's go ahead and add our sprint. We have our sprint input here. We have a sprint multiplier. It's going to be fairly simple. Here, where we construct our horizontal move, I'm just going to check if sprint input, well, if the sprint input is true or if it's false. So if it's true, I want this horizontal vector to be move times move speed multiplied by the sprint multiplier as well. Otherwise, we're just going to do it like this. So to do that, I'm going to just create a new horizontal here, a new vector 3, horizontal. And let's set it in here. So horizontal equals move multiplied by move speed multiplied by sprint input multiplied by time dot delta time. I accidentally put sprint input here. What I'm looking for is sprint multiplier. And so hopefully this is fairly straightforward. If we are sprinting, we just use the sprint multiplier. Otherwise, we don't use the sprint multiplier. Let's see that in action as well. So I'm walking around, not holding sprint. Let me just make the ground a bit bigger so we can see this properly. And if I hold shift, I start moving faster. This might be a little hard to see because the ground is all the same color, but when we hold sprint, we move faster. Okay, just to show it a little better, I just downloaded a little texture and put it on the ground so we can see ourselves moving and see that sprint working. You can see it's walking, and when I sprint, it's moving faster. And because of the texture on the ground, we can actually see that change in movement. Right now, one of the things you might notice is when I jump and I move, my movement is the same as it is on the ground. We can change that. I'm not going to change that quite right now. When we actually start using the state pattern, I'll change it. But that's, again, something that we might want, right? Like in the air, we don't want as much control as when we're in the ground. We could change it with this logic as well, but I'm just going to wait till we use our state pattern. But really all we're going to do is if we're not grounded, the same movement multiplier will be multiplied with an air movement multiplier, and that's just going to be something that's, under the value of 1. So it's going to be reducing our movement. the last little bit I wanted to add, and just kind of to, add something that's nice, that's common in games, and that is a feature that most of these platforming games have, called coyote time. So, and what that is when we jump, or when our character walks past an edge and they hit the jump key, the games normally give them a small grace period, a few frames where we have actually left the ground, but we can still hit jump. And the games feel really good when we have this. I'm sure you guys have noticed it as well, maybe. But some games, especially platforming games, you feel like you can jump right at the edge. And there's a certain amount of grace when we do that, and that's because of this coyote time. The name comes from the Roadrunner cartoons. Wile E. Coyote would sometimes like walk right off a cliff. He would kind of just hang in the air while he shows some signs like, uh-oh, I'm going to fall kind of thing. And then he falls down. That little time where he's just kind of hanging in the air, that's coyote time. It's basically us giving our players a little bit of grace period from when they walk off the edge to press the jump button. And so I'm just going to show you how we could add that. So to our jump controls, or to our jump variables, let us add another float. And I'm going to call this coyote time. Give it some small values, so, maybe 2 milliseconds after they leave the air, or after they leave the ground. That's how long I can let them jump. And then we actually need another float. That's going to be the timer itself. And the timer is just going to start as 0. So we'll do it where we deal with our updates. And it's super simple. Basically, if our character is grounded, we're just going to reset the coyote timer to the maximum time. So whatever time we set, as our coyote time, the timer is just going to be reset to that. As long as we're on the ground, that timer is going to be reset to its initial value. However, if we're not grounded, then the coyote timer, we're just going to keep subtracting it from time.delta time. So it starts at 0.2. If we're not grounded, every frame we're just going to subtract it by some small amount. Whatever it took to render that frame, we're just going to keep subtracting it. And now, instead of here where we do our jump input, instead of checking if we're grounded and we press jump, instead of checking that, we are just going to check if our coyote timer is greater than 0. So if our coyote, because when we leave the ground, that coyote timer is kind of going to keep counting down. At some point, it's going to cross 0, go below 0. It's going to be negative. If it's negative, we're done with coyote time. We're done with that grace period. Our player is not allowed to jump. If it's positive, they still have that grace period. Well, so then we can let them jump. And if they do jump, just so we don't let them jump again, we will set the coyote timer to 0. And so it'll be set to 0. Whenever they touch the ground, it gets reset, and that way they can keep using it. So if we go back, when we check it, I still can't jump. I can jump. I can even hold jump just like I did before. And that stuff still works the same. If we want to see the coyote time kind of in action, I'm going to just duplicate this and make a small slope. Maybe and now you'll see I can walk off this slope and then hit the jump button. And as soon as that grace period goes away, well, it doesn't let me jump anymore. But it gives us that little bit of grace period, and it makes platformers feel good because we can, it gives our player just a little bit more of that sense of control. We can also go ahead and tweak it. But yeah, that has been a simple video where we have created this basic character movement script. We have some options here you guys can choose to play with. You can even extend this script, add things like double jump, make it so you don't have to hold jump, you just press jump once and our character jumps. We can even like have a multiplier for our airspeed, so they don't have as much control in the air, maybe they have more control in the air. But we can keep adding functionality to this, all inside this update function. One of the issues here now is this update function is getting pretty bulky, right? The more features we add, the more functionality we add, well, the bigger this update function is going to get. And to help us kind of separate those different uses and concerns, that's where we're going to be using the state pattern. So we will take this in the next part and let's break it out into the state pattern and make our code a little more modular, a little more usable. And this will also lead us up into adding a character for Mixamo, as well as some animations to our game. Thank you guys for watching.